Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 14B. My name is Alesha Mulla, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on the 24th of February in London, and the virtual events are being conducted from 25th to 27th February via Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes to present and 3 minutes for question and answer. On the 10-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chairs for this session. Our first chair for today is Dr. Sheetal Nayan Girme. Dr. Girme is an assistant professor in the Computer Engineering Department at SCTR's Pune Institute of Computer Technology in India. She is a researcher in blockchain and distributed system security, with research interests spanning blockchain technologies, distributed system security, and algorithms and methods for coordinated election. Dr. Girme, I request you to say a few words.
Thank you, Alisha, for a nice introduction. And I'm looking forward for the research papers and the research work by the authors. I hope all the authors have joined the session.
Excuse me, I have a question if possible.
Yeah, sure.
I know I'm fasting, so can I present my work now? Then I can go to break my fast.
Okay, yeah. So you have Rosa, I guess. Yeah, that's the total decision of the coordinator. Alisha, you can manage the session. I don't mind rescheduling the paper presentation. Okay. I don't mind any sequence you follow.
All right, sure. I would be okay with that. Could you please let us know what your name is?
My name is Kamis Al-Karawi.
All right, of course. We'll just have the next session and next chair introduce themselves, and then we'll go ahead with your presentation.
Oh, thank you very much.
All right. Our next chair. Thank you.
Thank you.
Our next chair for today is Dr. Abiku Sam Iru, who is a lecturer at the University of Ghana Business School, where he specializes in digital technology, business analytics, decision science, and sustainability. His research interests include social entrepreneurship, creative consumer entrepreneurship, and AI-powered education. Through his work, he contributes to data-driven decision-making and innovative approaches to business and education. Dr. Abiku, I would like you to please say a few words.
Hey, hi everyone, and I hope you can hear me clearly.
Yes, we can hear you, Abiku.
Thank you very much for having me again, and I want to, just as my professor indicated, we are looking forward to an exciting intellectual conversation, and we hope that as academics, we will tolerate each other's viewpoint, even if we don't get to agree with any submission from anyone. So I'm happy to have you all and looking forward to a great time together. Thank you very much for your time as well.
Thank you, sir. So upon request, we shall proceed with Khamis's paper. All right, so our first presenter for today is Khamis Al-Karawi, who will be presenting phonocardiogram-based cardiac health diagnosis using machine learning techniques. You may now start your presentation.
Thank you very much. Yeah. Good afternoon. Thank you for taking the time to present my work. Today, I will present my work on using machine learning technique to analyze heart sound known as cardiogram for the non-invasive early detection of cardiovascular disease. The presentation outline first introduction and background, second research objective and cardiovascular disease context, phonocardiogram basis, machine learning model, feature extraction method, dataset description, methodology framework, evaluation matrix, key result for MFCC features, and key results for STFT features, comparative analyze, best performance combination, limitation, and finally conclusion and future work. Introduction cardiovascular disease, shortly called CFD, cause for death globally, about 17.9 million deaths annually, depending on the World Health Organization, and early prediction is crucial for prevention. The main challenge for that, traditional diagnosis require clinical experience, need for accessible non-invasive screening method, telemedicine, and resource-limited setting demand automated solution. The research objective of this paper is identify the most effective combination of machine learning model and feature extraction for BCG signal classification.
Sorry to
Yes,
interrupt you. Sir, can we make the presentation full screen, please?
yeah, I'll try
Slideshow
it.
view.
Yeah,
Yeah,
is
please.
that okay?
Yeah.
Yeah,
Good.
the
Good. Thank
specific
you.
aim of this work is evaluate multiple machine learning models, test virus feature extraction technique, find the optimal model and feature pairing, enable faster, more accurate cardiac diagnosis. What is the phonocardiogram? Is a non-invasive method for recording and analyze heart sound. And how it is work, sensitive microphone record, chest sound, capture timing intensively and frequency information, visual representation of cardiac sound beyond human hearing. Clinical value, detect numerous value problem and septal abnormalities, useful for heart failure detection, ideal for telemedicine and remote monitoring. Different model, machine learning model used in this work, like logistic regression and key-near snipers, decision tree, random forest, naive-bayes, adapose, and XG post. And for each one of model, there are different characteristics as clear in the screen. Also, we use MFCC, male frequency capital coefficient, as a feature. This feature captures spectral properties of sound and mimic human auditory perceptions, distinguish between normal and pathological sound. And the second feature is LBC, linear predictive coding, predictive signal value from prior samples, create compact spectrum envelope. And the third one is STFT, short time Fourier transform, time frequency representation, shows frequency evaluation over time, visualize as spectrogram. Dataset and methodology, dataset that use Viso.net Challenge 2016, comprehensive collection of hair sound recording, diverse patient population, and balance between normal and abnormal signal. Processing, audio convert to numerical waveform, standardization and normalization, and five-fold across validation. The framework is as shown in the screen. Start with feature extraction and then model training, validation, and evaluation. The matters for the use in this work for the accuracy overall correct prediction, precisions true positive over true positive plus false positive, and the low false positive equal highest precision. The second is recall true positive over true positive plus false negative, ability to find all positive samples.
Sir,
If
sorry to disturb you. Can you please concisely focus on the motivation first? Can you give me the motivation?
motivation for this work.
Yeah, please.
Yeah, that's as I said in the beginning, the aim of this work is to identify the most effective combination of machine learning model and feature extraction to predict BCG signal
Right,
classification.
sir. Yeah, correct. The one which you are reading and which we can find on slide seems to be the problem statement, the one which you want to solve. है ना? That is the aim and the target of your work, research work.
Yeah.
But
Yeah, the
the more
motivation, as I say, this type of disease is globally, and that motivate us to find like method just to predict the this disease before happen, using different machine learning from the sound that
okay.
recording from the
Yeah,
patient.
so sir, you mean there are no any existing solutions using ML for this problem, solving this problem, or there are some existing one, but they are not optimized yet. What exactly you
Yeah,
want?
there is a different solution, but we tried using the like machine learning to predict this thing, and to just to find which is the best or the optimal solution from the different solution.
Okay,
Uh,
and this is
yeah.
your PhD work, sir?
Sorry?
Is this your PhD work?
No. My PhD is different with this topic. My PhD in using the speaker recognition to
Mhm.
recognize the speaker from his voice.
Okay. So this is your another research work, parallel
Yeah,
to PhD. Okay,
yeah,
okay, okay, sir.
yeah.
Please continue.
Okay. Uh, Yeah, we like F1 is another method to evaluation. F1 equal to time precision, time recall over precision plus recall. Cross validations for fivefold ensure robustness. Best performance with the MFCC, we find the random forest with the high accuracy, 89.97, and the F square weighted is 90%. X G post 89, 88%, and the F square weight is 88%, and other post 86, 91, and the F1 is 87, K-nearest 84.43%, the F square is 82. Observation from this performance, random forest achieved the highest accuracy, 89.97. Naive Bayes exceed at the identifying apparent sound. Ensemble method outperformed similar models. Best performance with STFT features. The XG post accuracy is 31%, F score 88%, random forest, then KN, and finally other post performance is 86.44%, and the F score is 87%. The key finding, the features, STFT features yield the highest overall accuracy, XG boost 31%, time frequency analyzed proved most effective for BCG classification. Model performance across features, XG post with STFT Yeah. Just I can't see it because yeah, and London Force MFCC is 8997. Logistic regressions MFC over SST combination with the STFT is about 83.38%. Decision tree with MFCC is 82.81%, and naive Bayes with MFCC is 81 to 80%. The poor performance naive Bayes with the LPC 26.93, and naive Bayes with the Tonist 43.8. Top model with feature combination XG post plus STFT features performance was 91.31 accuracy, excels at capturing temporal and spectral information, and then random forest with the MFCC 89.97 accuracy, robust ensemble method with a spectral feature, and random forest plus STFT 88.44 accuracy, consistent performance across feature types. The main challenge identifying this work, data dependency, inconsistent performance across different data set may not generalize to all real-world scenario. Computation requirement, advanced model need to significant processing power, challenge for resource limited setting, and model-specific issue. Some model like naive-Bayes fail with the certain features, overfitting concern with the complex model, need for balance, accuracy versus computational efficiency, and model complexity versus interpretation. Key finding, XGBoost plus STFT features achieve the highest accuracy, and random forest consistently performed well across features. Feature selection critically impact model performance. Ensemble method outperform simple classifier. For the future work, we're recommending advanced feature engineering, like develop novel feature combination, explore deep feature fusion, real-time analyze, implement for clinical setting, edge computation solution. Third, extend data set, large, more diverse population, and multi-center validation. Hybrid model combine multiple approach, deep learning integration, clinical development, validation in real-world setting, integration with the telemedicine. Thank you for your time and for patience. Hello.
Yeah, thank you, sir. Thank
Thank
you
you very
for
much.
presentation. Yeah. Uh, uh,
I'm
Alisha,
sorry for rush become the time of breakfast now.
yeah, that's
Yeah.
absolutely fine, not an issue. Alisha, how do we address the second session chair, sir?
Dr. Abikusam.
Okay, okay, thank you. So,
Yes,
yeah,
okay. Yeah, so thank you very much, presenter. I just have just two questions to find out. In terms of the feature selection you did, are you able to indicate in terms of the feature importance? Because generally the models gives us which model performs better. But from your data set, are you able to identify or indicate in terms of feature importance, which features are more important in the issue of CVD?
The famous feature is the Miller frequency capacitor coefficient, and it is robust feature, especially with using like a sound signal. It is more robust than other type of features.
So I
Okay.
also had the question on same line, sir, as
Mhm.
Sam sir had. Um, so how did you, what parameters did you observe for identifying the attributes, and how many attributes you had in your data set, sir?
Sorry.
How many attributes did you have in your data set?
Depending on each machine learning are used, and there are five cross validation with the accuracy.
Okay. ठीक है. So how could you identify the best suitable attribute for the machine learning approach which you have implemented?
Uh, According to the machine learning that use, first we did each machine learning with each feature, and then in combination between machine learning with both MFCC with the STFT feature, and we find some combination of feature work good with the machine learning, and some features not good accuracy. We find not good accuracy.
Okay, so that was the best accuracy you could get, right? And
Yeah,
what
yeah.
percentage of data you have used for training and what percentage of data for testing, sir?
We about we're using about 80% from the data for training and 20% for testing, that just to see what is the
Okay,
more
so
robust machine learning.
correct,
Yeah.
correct. So the last question from my side. Have you drawn any architecture for the system which you have proposed? Or and the another question is, why did you choose this proportion 80/20 for training testing? Is this any magic figure, or you have chosen it randomly, or just because other researchers are taking the same proportion, or do you
Yeah,
find it relevant for
yeah,
your data?
I'm just in this work. I'm just trying to find good way to like for a prediction or detection from the data, because this I use one data, so I try to put like 80% just for training for all the features in the data set, and I put 20% just for testing to see the performance of each machine learning, and then the combination of feature with each machine learning.
Correct, correct. But I think we should have some proper justification for why 80/20. What? Okay, ठीक है, चलो, let it be. What would happen if I change the proportion from 80/20 to 70/30?
Maybe if I told you I use this percentage. Maybe if I change the testing to increase the testing
Hmm.
set like 30 or 40, maybe the result will be changed. Yeah, I
Result. Okay.
try to
No, but
do that in future work.
what would be the logical reason? Why would result change? Would the accuracy increase or decrease?
Because we like we have like a more testing, like a more percentage of data using for test. Maybe that will be the performance will be more robust because using different percentage of data for testing.
And how many labels do you have in your data set?
I'm not sure, but I try to do that and to send this paper for journal paper, so that I will use different type of testing and training, and maybe different data to see what is the robustness result can I get.
Okay, sir. Where did you find the data set from?
From a website
Which
I
website, sir? Is there any authentic website you have referred for getting the data set?
sorry.
What is the source of? I mean, which data set, website you have
Actually,
referred
I put it in the paper, but I forget to put it in the slide. Yeah, I put it
to? Okay, it's
the
okay.
source of
Okay,
the data in the paper. Yeah.
okay, not an issue. Did you find
Yeah.
any noise in the data set? Could you remove the noise?
Yes, that's absolute, because we have like a processing for the signal to remove the noise and the silent and the different thing in signal removal before you use it in the training and testing.
So pre-processing you have done. Okay.
Yes,
Yeah.
yes, and the normalization. Yeah.
Yeah. That's it from my side. Samson, you
Thank
can
you.
please
Thank you very
please
much.
ask if
Thank you very much.
If there's no further questions, should we move on to the next presenter?
yes,
Thank
please.
you.
Yes, please.
Thank you. Thank you.
Thank you.
Thank you. Bye.
Our next presentation for today is by Safa Walid Megzel, who will be presenting a comprehensive benchmarking of explainable AI techniques on camel-type dataset. Safa, you may now start your presentation.
Hi, I I will be discussing today our study on a comprehensive benchmarking of an explainable AI techniques on a camel type dataset. This is the
Safa,
continuation of
just a minute. Safa, would you please make the presentation full screen, please?
all right.
Yeah, we'll go by the conventional method, but I believe it would be great if you start with the motivation of the work and then the justification. Why did you go for this problem statement? I mean, that would be covered in the motivation even. And then this is benchmarking of explainable. Okay. And if any architecture or some kind of the representation you have prepared, that will focus on. And then you can go for implementation result. Okay. Safa, you can
All
continue.
right.
Thank you.
All right. I will be discussing today our comprehensive benchmark of explainable AI techniques on a camel type dataset. This is the outline. We will be first discussing motivation and the problem statement. Why did we conduct the study? The previous related work, our dataset and methodology, the evaluation metrics we use, and the results, then the conclusion. All right. Um, why did we conduct this study? Modern deep learning models like YOLOs and detection and classification models are powerful but opaque and lack transparency, which is related to our previous study um, on classifying camels as racing or non-racing, a binary classification. But we needed strong evidence to determine which features exactly represent these and differentiate between the two classes. Um, We found out that there is no standard XAI benchmarks for any animal imaging in the context of animals or UAE. There are available other benchmarks, but not on any animal datasets.
Okay, so Safa, as per my understanding, the problem statement you have chosen is identification of or classification of images for camels, right?
No, we are the study of the training model, and
Mhm,
it's already been done, but we would
mhm,
like to find strong evidence in the images to
mhm.
decide whether these are valid or not, and which regions determine which class is valid. But we have an issue that the current studies available do not represent these in the XAI explainable methods available in the research does not represent the results or determine which is the best method for deep learning models such as YOLO. Um, qualitatively and quantitatively at the same time. So we would like to go into these topics,
So as
and
per
we
my
would like to identify.
you are using explainable AI, right?
Yes.
Yeah,
Yes.
so you are using explainable AI and you are using it for camel breed identification.
Yes, 2 camel breeds.
Okay, okay. So you are just writing. What is the size, volume of the text you are generating out of XAI?
I will discuss it in the next slide if that is
Okay.
okay, or okay.
But then I didn't
Our
get.
aim,
Can you please specifically elaborate the motivation? Why do you need to, and where do you exactly need to identify and classify these camel breeds?
our
The
dataset
racing
is
sectors,
consistent.
UAE racing sectors,
Yes,
Emirates. Okay, okay, fine.
yes.
Yeah, good. Thank you. Continue, you can continue.
Okay. We're going to benchmark 9 different XAI models. We're going to evaluate them qualitatively and quantitatively using 5 metrics. And we are going to determine, per the results, the best method for XAI on YOLO layered architecture, specifically classification. Here is some related work. Most of the related work, as discussed before, uh, um, works with older models, but it does not discuss in deep the newer YOLO or YOLO versions, or version 11, version 12 in deep detail on animal dataset. Both qualitatively and quantitatively. Our dataset consists of 1,230 images in total. 952 are racing and 278 are non-racing. The non-racing dataset was sourced from Al Burida farm, and the racing dataset sourced from Al Maroon farm. Both datasets had issues with varied lighting, background, and camera angles. So we applied augmentation and after to balance the imbalance between the two classes. After that, we had almost around 2,000 images. Then we fine-tuned the YOLO V11 classification model and YOLO V11
Sorry,
classification model on this data.
Safa, sorry. Your voice is breaking. Can you shift to some stable network, please?
All right.
I'm sorry, my mouse is currently lagging.
Now this seems okay.
My device is currently lagging.
Yeah, lagging is okay, that we can understand. It should not break the voice.
No, my voice is my voice clear right now?
Yeah, better.
Okay. Yes, but my mouse is lagging. Can I use another device to join the session to continue the presentation?
You can do one thing, you keep this presentation live. If
Okay.
you have connected from the laptop or some other device, you can
Yes, I'm
join from
connected
your
from the laptop.
mobile phone for just using it as the audio input device. This you keep on.
No, my audio is fine, but my presentation is lagging.
Okay, presentation is lagging.
Yes.
Okay. You can just reconnect or something. Alisha, what we can do?
Yeah, Safa, you may reconnect from another device.
Hello, hello.
Actually, we can hear her. I don't know why you have. I think you have the problem from your side, maybe. Does anybody else having any problem in hearing Safa?
Her audio
Hello.
is fine. The issue was that her device was lagging, so she's requesting to join from another device. We'll just allow her to do that.
Hello.
Yes, Alonso.
Hello. Could you please let me know what time I supposed to present my paper? I arrived late. My name is Abdurrahman, please.
All right, just give me 1 second.
Okay.
You should be able to present in another half an hour.
Okay, thank you.
All right. While Safa joins back, we'll move on to the next presentation. Our next presenter is Bernardo C. Rodriguez, who will be presenting Comparing Local Neighborhood-Based Collaborative Filtering Variants, a Trade-off Between Prediction Performance and Coverage. Bernardo, you may now begin your presentation.
Sure. Can you guys hear me? Can
Yes,
you see
can.
me? Great. I will share my screen.
Yeah. We can hear you.
Did the slides arrive?
Yeah.
Great. So good afternoon, everyone. Thank you for all being here. I'm Bernardo Rodrigues, and today I'll present our work comparing local neighborhood-based collaborative filtering variants, a trade-off between prediction performance and coverage. This research was developed at the University of Campinas in Brazil in collaboration with Rosana Veronese from UC Louvain in Belgium and my supervisor, Professor Fernando von Zuben. This paper is based on my master thesis, where we conducted a deep dive into multi-objective nature of the local neighborhood methods. Let's start with why this matters. Well, we all are familiar with the information overload phenomenon. That is the feeling that you have when you have so many options that making a simple decision becomes difficult. Recommender systems are the primary tool we use to filter content according to user preference. A popular approach is to use collaborative filtering. We look at what like-minded users liked in the past to predict what you might like now. But there is a problem. Traditional CF employ global analysis that often miss niche patterns, especially when data is sparse. To address this, we use local neighborhood-based collaborative filtering, or LNBCF. These use pattern mining to find latent relationships in smaller, specific submatrices of the data. So what's the catch? Local methods are by definition restrictive. We only recommend items found within these discovered local patterns. So here we have an inverse relationship. As we push for higher accuracy by focusing on these high confidence by clusters, our coverage drops. The model simply has no access to more items it can recommend. And on top of that, finding these patterns takes time, which increase our computational cost. This balance between accuracy, coverage, and runtime is the core of our analysis. So our goal was to see if we could optimize accuracy or any other performance metric without compromising coverage. We use the BBCF framework, which is a specific state-of-the-art LNBCF implementation, and tweak its internal steps in order to answer the following 3 questions. First, is there a single variant of this algorithm that is better across all metrics? Second, how do objectives, that is our optimization metrics, relate to the specific variance? And finally, how sensitive are these variants to fine-tuning? So with the Pareto frontier, we aimed at finding a systematic way to choose the right model for the right job. So now let's take a closer look at the BBCF itself. It works in 5 stages: the pre-processing, the mining of the patterns, the selection of these patterns, the building of the neighborhood, and finally, the making the prediction. One of the advantages of the BBCF is that it's highly modular and agnostic, so you can easily swap out its components. For example, you can use any bi-cluster mining algorithm with it. As a matter of fact, that is one of the changes we tested. Also, though we have used the traditional KNN, like the original implementation for the final prediction step, you could, in theory, use any filtering strategy. In this framework, a local neighborhood is treated just like any other neighborhood. So here in green are the modifications we proposed to the original implementation and their respective steps. These modifications were tested individually and combined with one another. First, for the pattern mining step, we brought BINAPs as an alternative to the traditional cubic 2 algorithm that is used in the original implementation. BINAPs is a neural network approach using autoencoders. Second, for the pattern election, we proposed the compound weight frequency similarity metric that was designed to prioritize larger and denser patterns. Finally, we experimented with the prediction step itself. We tested both user and item-based KNNs combined with different similarity measures like cosine similarity, as opposed to the adjusted cosine, which is the one used in the original implementation. So by mixing these options, we created 8 different variants of the BBCF and tested it against another standard global benchmarks in the recommender system ecosystem. We ran our tests on the Movie Lens 100K dataset, which is a standard benchmark for recommender system studies. It has about 94% sparsity. We used 5-fold cross-validation, and we performed an exhaustive hyperparameter grid search that included over 4,000 different configurations. Our evaluation was consistently multi-objective. For each configuration, we measured accuracy through mean absolute error, ranking quality through precision recall, and prediction coverage, and finally, total runtime. So on the right, we can see the variants we tested. The modification employed in each variant are shown in green. The first one is the Canon implementation in BBCF. And these variants were tested against 4 global baselines: standard versions of the KNN, SVD, and SVD++, which are matrix factorization models for recommended systems. And here's what we found out. So this graph shows global Pareto frontier for accuracy versus coverage and recall versus coverage. To build this, we combined the results of every single experiment we ran, and then we extracted only the non-dominated solutions given the desired metrics. The first takeaway is that there is no universal winner, since multiple variants families populate the Pareto frontier. Actually, we see families excelling in different areas. For instance, on the left, we see that item-based variants are good candidates for maximizing accuracy. And on the other hand, and when we look at the right, user-based variants are better for retrieval tasks. In conclusion, the best model isn't a fixed thing. It is application-specific, and that means that it depends on what the decision maker values most. We also looked at how fine-tuning hyperparameters affect each variant. We found that this impact is also not uniform. As you can see in the figure, some parameters are critical for one goal, but somewhat irrelevant for the other. The election parameter, KTP, for instance, greatly influences recall, but has a shy effect on mean absolute error. Another example we've seen was that the standard item-based BBCF was very sensitive to the number of neighbors K and the KNN step, the prediction step. But when we added our CWF metric and the cosine similarity, the model became much more robust and stable to variations in K. So this means you can't auto-tune for everything. The tuning should be done according to the target performance metric and the specific variant. In real-world applications, we usually have constraints, like I needed at least 60% coverage. This graph shows that the optimal solutions shift as these constraints are imposed. A variant that is ideal when you're just fine with 20% coverage might be a terrible choice when you need 80%. This leads to our third conclusion. You should define your operational requirements first because the best model is a moving target. Stakeholders should pick the architecture that fits their specific balance between performance, coverage, and time, according to the Pareto frontiers. So to wrap up, I would like to leave you with these three takeaways. First, no universal non-dominated variant. Families, as we've seen, have tendencies, but no one wins everywhere. If there was a single best algorithm in these scenarios, the whole frontiers will be composed of a single variant or even collapse into a single point. However, we found some clear dead ends. For instance, every version of the Binaps miner, the autoencoder based one, was dominated by the other variants. So in this context, the cubic 2 algorithm that was used in the original implementation was simply more effective. Second, there's a fundamental trade-off between performance, coverage, and computational cost. Third, hyperparameter influence is application and variant dependent. This challenges the somewhat common ranking table approach we see in recommender systems papers, claiming that the new state-of-the-art based on simple results on a single table that is often misleading. As we've shown, an algorithm that looks like a winner in one region of the frontier might be useless in another. Interestingly, we saw that even small changes, like choosing between simple or adjusted cosine, can create unique and valuable trade-offs. So in short, there's no silver bullet here. Thank you for your time. I'm happy to take any questions.
Okay. Would you, Bernard,
Yes,
would you go to the flow diagram, the one which you have shown?
sure. This one?
Okay. So data set you mentioned is the very first step and then pre-processing.
Yes.
Okay. And pattern set, local neighborhood. K patterns.
I'm sorry, could you repeat that?
Could you hear? Yeah, I said what logic or what mathematical expression or the formula you have applied for identifying or selecting top K patterns from the whole set of patterns.
So it is basically the compound weight frequency.
You mentioned as like pattern election.
Yes, the pattern election is based on the metric called weight frequency on the original paper, and we proposed a similar metric called compound weight frequency. These metrics are a function of the size, essentially the size of the submatrices. For instance, the modulus of the rows and the columns. If you see in the written
Fine.
paper, the function are defined there.
You have given the expression. Okay. Okay. And where did you find the data set from? Where you have downloaded
This
it
data
from?
set is very from the maintainer's website. It's a Movie Lens is a very traditional data set for the recommended system applications. It's the first data sets that everyone tries to use.
Correct. But where did you find it? Where did you get it from? Could you find
From
it
the
on some
official
website or
release.
some okay. And how many attributes did it have?
Well, it has I can't remember exactly, but each column is a movie, and each row it's an user. So I guess if memory isn't failing me, it's about 1,000 or 2,000 rows. So it's 1,000 to 2,000 users, and we have about 900 movies.
Okay, right? Or the column?
Yes, 900. It's about 1,000 to 2,000 rows and 900 columns.
Okay. So the same question which I asked to the earlier author. What is the proportion of data you have used for training and testing?
The proportion, well, we used a 5-fold cross-validation. So fivefold is traditional to use 80 to 20 because you get your data set and you split it into 5. So that gives you a natural 80 to 20 proportion. And fivefold seems to be a standard methodology in this use case.
Optimal. So what do you understand by standard? Which parameter would be affected if I change the 5-fold to 10-fold? I believe 10-fold cross-validation would be better. How do you justify 10-fold would not be suitable for your problem?
Well, I see that if you increase the proportion, you will resort to that dilemma that you may underfit or overfit your data. So I guess if you enlarge the training portion, which means increasing the number of folds, you have more chance of overfitting to the data. And the opposite is also true. If you decrease the number of folds, that will give you a larger proportion of train to.
Have you tried doing it? Have you tried doing it? You didn't try. And then you just randomly came to conclusion 5-fold is the optimum one for your problem?
No. As I said, 5-fold cross-validation, it's a very common methodology on recommender system papers. So we just maintain this.
Okay, so you try to use the standard one. The
Yes,
one which
exactly.
is used in regular practice. Okay. Okay. So I don't have any further question. Yeah, thank you.
Okay. Okay, so Bernardo, thank you very much for the presentation. I want to find out overall, is it coverage or prediction when we are using bi-cluster based collaboration filtering? Is your study addressing more of performance or coverage in terms of the movie that we may, as maybe a user, If the recommending system wants to recommend the movie lens, let's say company, will it be more of a coverage or a performance?
Yes, nice question. Well, initially, the goal was to try to find some strategy to improve performance without hurting too much of the coverage. However, we found out that that was much more complex than we thought initially, and it was way deeper. It went way deeper than we thought. We did not manage to get better performance without hurting coverage. So that's essentially the finding here, that we were not able to improve performance without hurting coverage, unless we resorted to some kind of fallback strategy. There are other papers, other works that people already published that go on that strategy. That if the local neighborhood collaborative filtering fails, it fallbacks to another more general model, such as plain KNN, and then use it to recommend. So it's a hybrid model. But if you stay only with the local neighborhood collaborative part of the solution, we were not able to improve performance without hurting coverage.
Okay. Okay, thank you very much. My last question, though, is more for very practical implication of the CBCF for movie lovers and for industry players. What will be the practical conclusion of this work or your study that you've done?
Well, I believe that you shouldn't have like a precondition of which model you should choose. So each application, I think, will be specific, and you should try to perform some kind of benchmarking a priori with some kind of restrictions in mind, so you can draw a Pareto frontier such as these, and you ask the decision maker, the owner of the system, and ask him, so which is the threshold of coverage that you're comfortable with? What's the computational cost that you are willing to go for? And this is how much precision I can give you with these two constraints, for example.
Okay, thank you very much. Thanks. I really love your work. Thank you, guys. And thank you. Alicia, thank you very much. We can proceed.
Thank you. Thank you very much for your questions and comments.
Thank you, Bernardo. I believe Safa is back in the meeting, so we should continue with her presentation.
Shall I restart, or is it okay if I continue onwards?
You may continue.
Okay. Continuing with the previous subject, our dataset consists of 1,230 images. 952 were racing and 278 were non-racing camels. These were extracted from two farms, Al Burida and Al Marwa. Due to variety in lighting, backgrounds, and camera angles, we had to opt to correct the images and apply augmentation to equalize the non-racing and racing camel class. Then we fine-tuned two YOLO V11 models per a previous study in the for classification only. After this, we'll proceed with testing 9 explainable AI methods to determine which model was faithful and accurate with the detection areas or differentiation areas between two classes. This is a good image to describe the pipeline overall. We are only using the 252 test images that were excluded from the training and the validation parts of the model. Then we are running it through our YOLO model classification, applying each and every XAI silence over A method. Then we're going to evaluate these methods qualitatively and quantitatively. Here are the evaluation metrics. First, we're going to evaluate for faithfulness with deletion over AUC. This one will measure the prediction confidence as it drops when the most important pixels, the most deterministic pixels of the class are removed. The lower it is, the better. This is for faithfulness. For localization, we are comparing our image with the ground truth masks of the camel itself, and we are we're looking at the highest pixel, determining whether it's lies within the mask, and also we're looking at the area overlap of the pixels, correct predicted pixels with the mask itself. Finally, we're going to decide the error between the prediction and the ground truth mask as well, whether these lie within the ground truth mask or deviate, and we're going to use two metrics, root mean square method and Pearson method. The Pearson method is a linear correlation between the heat map and the ground truth mask, and the root mean square method is an average error between the predicted heat map mask and the ground truth mask. This is the quantitative analysis. As you can see, we have an issue with the average IOU. It's generally low, and that is because for our study, we have fine-tuned the mask specifically to only detect camels and differentiate between only two classes. So this is a good indicator. Lower IOU means the model was more accurate with its predictions. So YOLO V11 was more specific and accurate than YOLO V12 classification. Regarding the comparison between overall, regarding the comparison between each and every XAI method, we found that GradCam, LearCam, HighRiskCam best perform with YOLO V11 because they have the lowest error and the best faithfulness. Regarding the YOLO V12 performs with better localization, but deletion AUC, as you can see, shows that our predictions are noisier, which is correlated also with average IOU that's higher. This is the best method so far. They've been ordered according to the quality of performance qualitatively by looking at each image and comparing with the ground truth mask and the original image. We have found that LearCam performs the best overall. It focuses on object features and with minimal background interference. GradCam comes second place with strong faithfulness, but more interference in the background and more area within the camel itself. HighRiskCam has detailed localization and it's consistent overall, but it comes third place as both of these two methods above perform better than it. GradCam perform equally the same, but it's been ranked as fourth place due to moderate background interference. XGradCam performs equally the same. IGenCam and IGenGradCam both have the same issue with the interference with the background. Good localization, but a lot of background interference. Unfortunately, RiseNCam performed very poor because of the YOLO V11 layered architecture. It did not reflect very well, and areas were not. First, they required high processing power, and the areas did not reflect the camel itself and were blended all over the image when both ground truth mask and heat map were combined. This is the conclusion to our work. GradCam, LayerCam, and HighResCam, per the results, performed the best overall for any YOLO architecture. GradCam has been the most successful across both of the architectures, YOLO v12 and YOLO v11 classification. And as we can see, not a single XAI method excelled in all metrics. Also previously discussed, IOU method, IOU was nearly zero by design because we are looking for classification, not a detection model. YOLO v11 overall was more faithful, and YOLO v12 had better localization and but noisier heat maps. Lime failed visually, and Rise performed the worst overall after Lime. For future work, we aim to extend the study for previous YOLO v8, YOLO v9, and YOLO v10 models across this dataset. We aim to also look for implementing XAI in the segmentation portion of the study of the pipeline. Instead of just working with the classification model, we aim to work with a better data set with more racing versus non-racing camels. As we concluded that our XAI method, our XAI model, focuses on the camel's head, tail, neck, and hump legs for to distinguish between each two classes, racing and non-racing, and we aim to work with better standardization of the metrics that have been used. And that's all. Thank you. I would like to ask if there's any questions and discussions.
Yeah, so Safa, before Dr. Shita comes in, did you say your study was qualitative, quantitative?
Yes.
Okay, so which aspect of the analysis that you've done reveals the qualitative outcome, if you like to?
Okay. For the qualitative outcome, we were looking at the original camel image and then the isolated camel mask, because each image might have more than one camel, but we looked only at one isolated camel for each image without considering any of the background. And then we compared the highlighted regions. Red identifies the highest indicator, and green is the weakest indicator of the region. One issue here, as in the top image, the camel is highlighted very specifically around the edges, and it does not involve any background, which indicates visually that these certain features are the ones that affect the middle decision whether to classify it, whether it's racing or non-racing. In this case, this camel is actually non-racing. In the second image, we can see there is an issue, there is an interference with the background. This reveals that these ones have the highest effect to determine the class of the camel, but there is an issue with the background, which is why YOLO v12 was considered to have noise. YOLO v11 was more constrained with the mask.
Okay. So my last question is, why explainable AI when you could have chosen other methodology or other models to look at the predicting these two possible outcomes? Why explainable AI instead of maybe other models in question?
All right. That is because explainable AI is the easiest model to interpret of these deep learning algorithms. It's the easiest to visually interpret for day-to-day users. Suppose the normal person needs to use this application to determine whether this image reflects a certain characteristic. If they are not professional, or if they are not If they're business oriented, they would like to have a simpler solution to find out whether this object within the image reflects or classifies it correctly and fastly. يعني.
Okay. I
Would
would
you
have
like?
I would have just indicated that there are other perhaps models that we can use without saying that we did qualitative, quantitative, but the study could still be quantitative and we'll still be
Yes.
able to visualize the outcome well. But at least it's your work, so I guess it's more adaptable to the data that you use. So thank you very
Yes.
much. Dr. Shita, please you can take over.
Yeah, thank you, sir. Actually I had discussion with Sava when she started presenting initially, and then I have the question. Like
Yes.
as sir said, if we can go for classification model, why XAI, like explainable AI? And if you have answered it like I guess it is easy to implement, right, Safa?
Yes.
Was that your
Yes.
answer?
It is.
Yeah. So if it is easy to implement, then does it put any overhead to the
It is easy to implement, but because it's easy to implement and there is not much research in this, not much focus in this area, we have not found the best XAI method to represent our models without error. We would like not to have error when using this easy model. So it should produce a
how
good
many?
result.
Okay, so how many categories you are classifying the camel in?
Currently, only two categories, racing and non-racing.
That's what I'm telling you. Why didn't you go for classification? That could be better. That could be faster
Oh,
than
we
XAI.
already did classification.
Okay.
But
And
we
then you
want to
are using,
identify the features that
okay,
determine the
okay,
classification.
using XAI, right?
Yes. And we also need to determine as the researchers whether our model is using the background as reference to decide whether this object is or is not. We would like to make sure the model does not use the background as reference. We want to focus only on the object.
Okay, so have you done any image processing? Pre-processing you must have done, right?
Yes.
Okay. And then you have used hit map method?
Yes.
Okay. Okay, seems good.
These methods.
Yeah, seems good to me. Thank you, Safa.
Thank you very much.
All right. Our next presentation for today is by Geraldine Dwarka, who will be presenting Developing Computational Thinking Through Coding, a case of South African public primary schools. Geraldine, you may now start your presentation.
Good day to the chairs and fellow colleagues, wherever you may be in the world. Greetings from a rainy city of Durban in South Africa. My name is Geraldine Dwarika, and I am a programming lecturer at the Durban University of Technology, but studying at the University of KwaZulu-Natal. My respected supervisors and co-authors are Dr. Rosemary Kulling and Professor Irene Govender from the University of KwaZulu-Natal. Public school education impacts the most vulnerable in society. And as researchers, we have an obligation to address challenges facing our young children. Today, I am excited to tell you about our recent study on developing computational thinking through coding, which addresses the critical challenge that teachers are faced with, particularly in South African public primary schools. My presentation has the following content, and I will take you through it during the course of my talk. The phenomenon of this study, computational thinking, solves daily problems and ideas with concepts that stem from computer science. The founder of computational thinking, as you know, Professor Jeanette Wing, emphasizes the importance of cultivating the analytical ability of every child with computational thinking skills, just as they are taught to read, write, and perform arithmetic. Core elements of computational thinking include decomposition, breaking down the problem, pattern recognition, identifying similarities, abstraction, focusing on elements, algorithms, creating step-by-step instructions, and debugging, assessing the solution. SDG 4 enforces inclusive and equitable quality education and promotes lifelong learning opportunities for all. Our colleague presented on SDG Goal 9, which aims to build resilient infrastructure and foster innovation by 2030. And so too, the goals of our study align to this. In addressing at least part of these SDG goals, it is necessary that all schools are equipped with competent teachers and solid infrastructure to be able to offer coding in the curriculum. Embracing the 4IR era is a need that prevails in our South African public education sector. Several studies affirm the use of coding as a vehicle for computational thinking development. A significant improvement in children's ability to solve computational problems can be seen when they practice coding in school. The sad reality is that a number of teachers from public primary schools are not trained and capacitated to teach coding. Teachers struggle to enact the coding and robotics curriculum that develops computational thinking concepts and practices amongst learners. Teachers lack a clear understanding of how to factor computational thinking into K-12 educational practices. The degree to which intermediate phase teachers are incorporating computational thinking through coding in the curriculum remains unclear in South Africa. Such concerns are prevalent amongst public primary schools in low economic areas. This study explores a praxis-based conceptual pedagogical curriculum framework to develop computational thinking at the intermediate phase in public primary schools in South Africa. This is achieved by mapping core computational thinking mental elements against learning engagement dimensions using coding as a vehicle. Learning engagement relates to how students participate in tasks and activities within the classroom. The underpinning learning theories are constructivism, social constructivism, constructionism, and problem-based learning, PBL. Teacher facilitation was guided using the TPAC framework and ZPD theory. The computational thinking evaluation dimensions include coding concepts, the knowledge component, computational practices, the skills component, and computational perspectives, the attitude component. This paper was guided by the following research question: what computational thinking skills do the teachers exhibit prior to a coding intervention? Moving into the research design and methodology, 17 schools located in KwaZulu-Natal were invited to enroll intermediate phase teachers at a 7-hour teacher workshop conducted over 7 weeks. It involved contact lessons on how to enhance computational thinking through Scratch coding. 40 participants, mainly grade 4 to 6 educators, enrolled for the training. Informed consent and pre-test questionnaires were administered to all 40 educators. The questionnaire elicited demographic details and prior experience with computational thinking and coding, as well as closed-ended and open-ended questions to provide an understanding of the computational thinking skills that they exhibit prior to the teacher workshop. This paper discusses the findings from the pre-questionnaire used to elicit the computational thinking perceptions of educators as a precursor to the development of the CT framework. 70 closed-ended questions were based on a 5-point Likert scale from 1, strongly disagree, to 5, strongly agree. Regarding teacher prior experience with computational thinking and coding, 48% had never attended any coding training workshops, and 63% had never tried programming in their personal life, while 43% were not at all familiar with the term computational thinking in education. Only 8 of the 40 participating educators, that is 20%, had prior exposure to using Scratch. Yet they all unanimously agreed that Scratch is an age-appropriate tool to teach coding to intermediate phase children. Most educators, 85% and above, expressed that they would benefit from a platform that provides shared resources, discussion forums, and communities to foster collaboration, social interaction, and communication. This finding highlights the need for an engagement platform for sharing of ideas and teaching materials. Findings affirm the need to support teachers with their knowledge of computational thinking through coding. Teachers cannot teach something unless they know and understand it themselves. Regarding the definition and usage of computational thinking, 90% accurately recognized computational thinking as the ability to think logically to solve problems. A positive attitude emerged as 80% felt that computational thinking can be incorporated in the classroom by allowing students to problem solve. PBL received the highest percentage, 95%, as the learning theory that was used in the classroom. Teachers were prompted on the adequacy of support received from the South African Department of Basic Education, or DBE, to teach coding concepts using the coding and robotics curriculum. 25% of the teachers indicated that they were unsure, while a fair percentage of over 55% disagreed that they received adequate support. These two groups together make up 80% of the sample, with only less than 18% being positive. Similar findings emerged across all 5 core pillars, with 45% and above of teachers in disagreement and 15% unsure that they received adequate support from the DBE to teach coding practices. Teachers also expressed higher levels across disagreement and neutral responses when questioned about the adequacy of support from the current DBE coding and robotics curriculum towards teaching computational perspectives. In response to the research question, the findings indicate a lack of computational thinking skills prevalent amongst the majority of participating teachers. A concerted effort related to coding interventions are required to support teachers' involvement in coding practices towards developing computational thinking in South African public schools. Furthermore, a computational thinking framework integrating coding activities for teachers in the primary phase should be developed to guide teachers and other stakeholders in developing computational thinking. I would like to thank ICICT 2026 for affording me the opportunity of presenting this paper and you, the audience, for listening.
Okay, well, thank you very much, Geraldine. I was excited when I read the abstract of the paper earlier. So my question is there a continuation to this study? After these findings, is there a continuation to the study?
Yes, Doctor, there is. This is a precursor to larger scale study. So essentially, there was a case study that commenced hereafter, and a secondary case study that took place after the first one. So a lot has been done since the first information has been presented at the ICICT conference. And we will be, hoping to publish these results going forward.
So from where I sit, I'm excited to hear how we can, in our curriculum now, coding becomes more like a core subject for maybe from the primary level. We are even pushing for engineering education from the primary level. But I need empirical evidence. So like your case, why I'm asking for further studies to say that there is an empirical study that says that coding actually have an impact on critical thinking. Then we have an evidence-based study from perhaps Sub-Saharan Africa. How can we push our policymakers to see that coding is very essential? I see your work to be more qualitative, but perhaps maybe if we can use the same, let me say, the construct to measure the real impact. We test, we bring in like a paired kind of study, paired sample study. We bring students without prior knowledge of coding. Then maybe after a period of time, we take them through coding. Then we can now assert to policymakers that this is the direction for Sub-Saharan Africa. So perhaps I'll also be more interested after the presentation to get in touch to see how these conversations can be elevated, especially at the primary level from Sub-Saharan Africa, from where I see. I can't say the same for Dr. Shita, maybe from India, where she is, but this is Sub-Saharan African issue, and it's more critical in our policy direction now. So thank you very much.
Yes, sir. At least I came to know the issues you people are facing, and I would also love to participate and collaborate in case if you want. So I'll be happy, sir. I'll be happy.
Great.
I would also
Great.
like to
Thank you.
contribute. So
Thank you very
problem
much.
solving approach we are right now facing on, as we are, we are at higher education and all. So we are now facing the challenge of problem solving approaches and different strategies to be used for solving the problems. But at childhood stage, we do face different kind of problems. So we need to address them differently. Correct.
Absolutely.
Yeah. So
Thank you.
excellent work, Dwarika. Thank you. Thank you.
Thank you.
All right. So our next presentation for today is Abdul Rahman S. Elenizi, who will be presenting Evaluating Machine Learning Techniques for Automated Hate Speech Detection. Abdul
Yeah,
Rahman, you may please begin.
yeah, I hear you. Just need to share the screen, please. It's shared now. It's shared now.
It's
You
loading.
see my
Second.
presentation? You see my presentation
Yes,
now?
we can see it now.
Okay. Okay. Hello, everybody. Good afternoon. Thank you for giving me this opportunity to present today. My name is Abdul, and today I will talk about how we can use machine learning to automatically detect hate speech in social media. The topic is very important because hate speech is spreading quickly online, and we need to smart solution to reduce it. I hope you enjoy the presentation. Today, I will talk about how we can use machine learning to detect hate speech automatically on social media. The goal of this research was to find which machine learning method works best to detect hate speech in tweets. Nowadays, hate speech is spreading very fast on social media. Humans cannot check millions of posts every day. It is sensitive and slow, so we can need a smart system that can detect hate speech automatically. Many researchers today tried different machine learning models, but there was no clear study comparing many models together on the same dataset. So the bigger question was which model and which text method gives the best result. The researcher used more than 14,000 tweets. The tweets were divided into three groups: hate speech, offensive but not hate, and normal tweets. 80% of the data was used for training and 20% was used for testing. Before using machine learning, the text must be cleaned. They removed unnecessary symbols and made all letter lowercase. After cleaning, the text was converted into the number because the machine learning cannot understand words directly. They tested three ways to convert text into numbers. The first method was TF-IDF with background. The second one was word. The third was DOC-FAC. Each method presents text differently. The tested 8 different machine learning models. For example, support factors machine, random forest, Tiefenbeis, and other. Total, they test 24 combinations because they tried very feature method with very models. The best result came from the combining TF-IDF with the background and using support vector machine. This model achieved 79% accuracy. It's performed better than all other combinations. This model worked because background keeps word order. TF-ID shows which words are important, and SVM is very strong for text classification together. They produced the highest accuracy. In conclusion, support vectors machine combined with TF-IDF background is the best solution in this study. This research gives strong starting points for the future work. For future work, future research can use large data set and deep learning methods to improve accuracy. Thank you for listening. Any question? I'm ready to answer.
Actually, I do have a few questions.
Okay.
Yeah, Dr. Sam, would you like to start? Then I'll take it then.
No, you can proceed. That's fine.
Oh, okay. So, can you go to the very first slide, please?
Yeah, okay. Which first one or?
The first one.
Yeah. Okay.
Yeah.
Okay.
So this is about evaluating. No, go to the title slide.
Titles. Okay. Evaluation, machine learning.
Machine learning for hate speech detection. Okay. So this is about hate speech detection, and you have used Twitter data for the same.
Yeah.
Okay.
Yeah.
And which model could you find is the best suited for identifying or identifying the hate speech, detecting the hate speech?
Okay, the research focusing on using machine learning to automatically detect hate speech. In social media, especially Twitter, hate speech is spreading quickly, and it's very difficult for a human for manually check millions of posts every day because it's the slow and expensive. The solve this problem in this study compared different machine learning models on the same data set of more than 14,000 tweets. The tweets were divided in three categories: hate speech, offensive, large, and normal speech. The data was split in 80% for the training and 20 for the testing to evaluate performance fairly.
Did you say 85? Sorry, did you say 85 for training and what
Yeah, yeah, for 20 for testing to evaluate performance fairly.
80 for training and 20 for testing, you said, right?
Yeah, maybe you want to ask me why did you choose the 80 or 20 split for the rating and testing? I
Okay.
know.
So what would be your answer?
Yeah, because we use 80 or 20 spelled because it's a standard practice in machine learning.
Listen to me. Just a minute.
Yeah.
So when we say something is standard, you know?
Yeah.
So if you are saying this 80-20 proportion is standard, then is it defined somewhere that it is standard? I don't think so.
Yeah. Yeah, but this is common. It's common standards spelled in machine
No,
learning.
you should explain it. Just a minute. You should explain it as it is widely used and it gives you the better result. Probably if you change the proportion, the model will overfit or underfit, or you will have some incorrect result. This can be your answer, but this is the standard proportion. Probably may not be the correct answer to this question.
No, because 20% provide reliable and effectively, like unbased, like for unbased evaluation of the performance on the.
Did you say unbiased? Unbiased?
Yeah, unbiased. Yeah.
Unbiased. Okay. Okay. Fine. Fine. Yeah, no more question. Dr. Sam, if you have any question.
Yes, Alliance. So you got your data from, take me through your pre-processing. How did you do the data pre-processing? I mean, from Trader, you said you got the data from Trader. So what did you go I need to understand your data pre-processing stage, if you would like to share that.
Yeah, it's okay. But it's very good question. Thank you. Based on the result on this study, the key factor was combination between feature and extraction and the classifier. The performance depends mainly on how well the text were present and how effectively the model separated the classes.
I guess, Dr. Sam, you asked about the pre-processing?
Yes.
Yeah. So you are supposed to explain what method for pre-processing you have used, and could you find any noise in your data? And then how did you remove the noise?
Yeah, because on the main, you're talking about challenges. Challenge was that some words or appear.
No, not at all. Have you referred some data set? Yes.
Yeah.
Correct.
Do you mean what the contribution of this study like?
No.
No, so if like when you get data, ML, before you even train the data set for model, you do data imputation, you do other means to ensure that if there are outliers, there are
clean the
noise
data.
you generally cleaning the data, because I infer that you getting the data from Trader, there could be a lot of noise in the data. Otherwise, we can say that the fact that we use a model to train means that the study has contributed. But essentially, you are looking at how the model itself can be used to detect hate speech and its relevance.
I know, I get your question. And what, like, you mean what can be improved in future work, my work?
Okay,
Or
we've
it's
not got to
important?
there yet, but I mean, it's always important that we look out for just not the data in its entirety. I have data doesn't mean I can use it for ML model. There are a lot of
Yeah,
overfitting issue, a lot of noise, a lot of outliers that needs to be. So
yeah,
maybe before you guys run the model, you clean the
yeah,
data. So we are asking, what exactly did you do? Because if there are statements that looks the same and you are
yeah,
repeating it in the model, it's just like when we talk about multicollinearity, features could
yeah.
have the same predictability, but they are still being allowed within the data set. So just to ask, if you are not sure, that's fine, but I just wanted to know how play or pre-processing took place. Okay.
Yeah, and in this research, you mean in this research, we focus on comparing a traditional machine learning method under the same conditions. However, this area can be improved further in future work by using large data set or more advanced models.
Okay. Thank you
Yeah,
very
good.
much.
Abdul Rahman. Yeah,
Yeah,
I guess Dr. Sam, this is fine.
yeah, thank you.
Yeah.
Any
Just a minute. I
question?
had one question. I have one last question, please. Yeah, may I go for it? So I just want to know, are you a student of PhD or you
Oh,
are a
me,
working professor?
you ask me, sorry?
Yeah. I'm asking you,
No,
Abdul
no,
Mehmet.
I'm lecturer. I'm already PhD. I get PhD since a long time.
Okay. So this is your post PhD work you're presenting?
Yeah, just publication, just the practice.
Just additional research you are doing. Great. Thank you.
Yeah. Thank you so much.
Thank
Thank
you.
you. Have a lovely day. Thanks.
Thank you.
Thank you.
All
Bye.
right. So now we'll be moving on to our last presentation for the day. Up next, we have Aram Ningsi, who will be presenting the use of drone Emperor as a data-driven tool to enhance Muhammadiya's digital communication strategy. Aram, you may now begin.
Okay, thank you. Could you see my presentation, PowerPoint?
Yes, we can.
Yeah.
Okay, thank you. Well, good afternoon, everyone. My name is Arunisi. In an era where religious narratives increasingly unfold within algorithmic environments, my paper explores how Muhammadiyah employs drone emprit as a data-driven instrument to strengthen their digital communication strategy. Well, over the past decade, digital technology has fundamentally reshaped how religious organization committee engage and construct community. Social media is no longer merely a dissemination tool. It is a space where religious authority, identity, and interaction are negotiated in real time. In Indonesia, Muhammadiyah, one of the largest Islamic NGO, has adapted to this transformation. Beyond circulating religious messages, they seek to cultivate inclusive and dialogical engagement across platforms such as Twitter or X, Facebook, and Instagram. Muhammadiyah employs Drone Emprit, a big data analysis platform that enables real-time sentiment analysis, topic clustering, and social network mapping. Through this tool, the influential actors and assess how their messages are received and interpreted. This study, therefore, asks how does Muhammadiyah utilize data analytics to strengthen their digital communication strategy? Methodologically, this study adapts a qualitative approach in order to explore the meanings, experiences, and organizational contexts shaping Muhammadiyah use of digital analytics. The research consists of two complementary stages. First, I conducted a systematic document analysis of the report from Muhammadiyah published in February 2023. This report contains both quantitative and qualitative data on social media performance, including engagement rates, reach, and interaction levels. Analyzing this document enabled me to identify patterns of audience participation, message resonance, and the strategic development of drone imprint within the organization communication practices. Second, I carried out semi-structured interviews with 13 Muhammadiyah staff members, including directors, program coordinators, presers, and media personnel. These interviews explored how analytics are interpreted, how decisions are made, and how data-driven insights are integrated into everyday organizational routines. By combining document analysis with interviews, the study achieves both empirical grounding and interpretative depth, allowing for a nuanced understanding of data-informed religious communication. Before discussing digital strategy, it is important to briefly situate Muhammadiyah institutionally and ideologically. Founded in 1912, Muhammadiyah is a reformist social religious movement in Indonesia. It is deeply involved in education, healthcare, social welfare, interfaith dialogue, and civic advocacy. Its guiding philosophy is dakwah amar ma'ruf nahi munkar. That means promoting what is good and preventing harm. Participants in this study framed dakwah not as a dogmatic proselytization, but as an ethical and pedagogical process aimed at cultivating virtuous individuals and responsible citizens. Muhammadiyah grounds their mission in three interrelated principles: humanization, liberation, and transcendence. Humanization refers to affirming human dignity and ethical responsibility. Liberation addresses structural injustice, poverty, marginalization, and violence. Transcendence situates these commitments within faith in God. Together, these principles shape a model of da'wah that is transformative, persuasive, and explicitly non-coercive. This approach is further articulated through the concept of Islam berkemajuan or progressive Islam. Respondents describe it as an ethical framework promoting justice, democracy, pluralism, and social advancement, while firmly rejecting violence and extremism. Muhammadiyah also positions itself within the Indonesian constitutional framework through the concept of Darul Ahdi wa Syahada, affirming national consensus and peaceful civic coexistence. In practical terms, these principles are translated into civic education programs, human rights curricula, gender empowerment initiatives, environmental campaigns, and carefully crafted sermons promoting moderation. Digital platforms are strategically used in disseminate peace narratives and counter extremist
Just a minute.
ideologies.
Arum, are you moving forward in the slides? Because I guess we are on slide number. You don't have slide number, sorry. So
Okay. Yeah.
I guess, yeah. So which slide you are reading?
Still the
Overview.
previous one. Yeah. I reading about Darul Ahdi wa Syahadah. Yeah.
Okay.
Yeah.
I thought you are discussing something different. Yeah,
Uh,
please
yeah.
continue.
Yeah. Thank you. Well, so institutionally, Muhammadiyah is highly structured with now I'm going to move. Well, Muhammadiyah operates through a structured, multi-layered leadership system across Indonesia. It comprises provincial, district, sub-districts, and village-level leadership boards. Beyond its national presence, the organization also maintains branches operating internationally alongside leadership units that support their institutional activities. This extensive infrastructure demonstrates that Muhammadiyah is not a marginal religious movement, but a deeply institutionalized and nationally embedded organization. Such a scale shapes how digital communication strategies are designed, coordinated, and implemented, particularly when integrating data analytics into organizational decision making. Muhammadiyah actively employs multiple digital platforms, including Facebook, Twitter, and Instagram, to disseminate a message of peace, sometimes even using humor as a communicative strategy. However, operating in Indonesia's socio-political landscape means navigating sensitive issues, particularly in the context of violence and terrorism. The organization has at times faced stigmatization, including association with radicalism. Much of the existing literature portrays digital communication as inherently participatory and democratizing, a space where users simultaneously produce and consume content. However, the Muhammadiyah case complicates this assumption. Rather than responding reactively to online controversy, the organization adopts a cautious and data-informed approach using drone upgrade. They monitor real-time sentiment, engagement patterns, and the duration of public attention before deciding whether to intervene or remain silent. This reflects a shift from participatory spontaneity toward term strategic participation. Engagement is not automatic, it is calibrated. If a controversy dissipates within a few days, the organization may choose not to respond. If it remains silent, it may reframe the narrative strategically. This selective engagement demonstrates what respondents describe as a careful, measured communication culture. This practice represents more than technical adaptation. It illustrates a form of institutional reflectivity where analytical insights directly inform organizational decision making in real time. Big data in this context.
Excuse me.
Yeah.
I'm so sorry to interrupt. You have less than 2 minutes left.
Okay, thank you. Big data in this context is not used merely to maximize reach or engagement. Rather, it serves an ethical function, protecting institutional integrity, avoiding the escalation of attention, and aligning communication practices. So let me now turn to how Muhammadiyah operates their digital strategy in practice. The organization's digital division primarily use Facebook, Instagram, and Twitter or X as its main communication platforms. One particularly finding from the February 2023 Digital Insight report concerns the strategic use of humor through a caricature post on Twitter with humorous caption. Muhammadiyah generated substantial engagement. Drone Prit's analysis suggests that humor functioned as an effective medium for articulating alternative narratives of peace and tolerance. Interviews with media personnel further clarified this strategy. They note that many users approach social media primarily for entertainment by incorporating humor and increasingly hybridizing caricatures with photographs of community activities. Muhammadiyah makes its peace-oriented messaging more accessible and relatable. Well, because the time, so I will forward to the next one. Looking at the Facebook data in February 2023, I observed strong cross-platform engagement. Reach was particularly high, exceeding 63,000 users, with an interaction to reach ratio of approximately 44%, a notable figure for a faith-based organization. However, the conversation from interaction to link click was significantly lower, around 10%. This suggests that while audiences engage, translating engagement into concrete action remains a strategic challenge. Well, further analysis showed that news-related content addressing click-through rates, addressing contemporary socio-religious issues generated the highest click-through rates. This aligns with interview findings indicating that audiences respond most strongly to content perceived as socially relevant. Theoretically, this reflects narrative engagement. Persuasive impact increase when institutional values connect with live social realities. And then for the last one, I will now address Instagram, specifically Muhammadiyah account Lain Samu. During the observed period, the account recorded more than 3,000 new followers, nearly 70,000 profile visits, and others. You can see as the picture here. When we disengage the interaction data and pattern emerge, regular posts account for 92% of total engagement, significantly outperforming reels. Interview data confirm this trend. Muhammadiyah Instagram audience appears to prefer photo-based and carousel formats over short form video content. At the same time, the high number of saved posts over 9,600 suggests that users perceive educational and inspirational materials as valuable enough to revisit. This reflects what we may term a value-based engagement, where interaction is driven not merely by visibility, but by perceived moral or intellectual benefit. So as the conclusion, I argue that the utilization of drone emprit represent a strengthening of Muhammadiyah digital communication strategy as a modern Islamic organization. Through big data analytics, Muhammadiyah is able to monitor public opinion in real time, identify dominant topics and prevailing sentiments, and formulate communication strategies that are increasingly evidence-based and measurable. Drone emprit doesn't simply track message dissemination. It enables the organization to evaluate how their dakwah messages are received, interpreted, and responded to within digital spaces. In this sense, analytics becomes a mechanism not only of observation but of strategic reflection. What we see, therefore, is a broader paradigm shift in the management of religious communication from an institution-driven model to a data-driven one. Information technology is no longer merely a channel for broadcasting messages. It functions as a source of strategic knowledge that informs decision making, strengthens institutional legitimacy, and shape digital public image. The adoption of drone and print thus forms part of Muhammadiyah wider digital transformation and its ongoing evolution as a progressive Islam movement in the era of new media. Thank you.
Yeah, Dr. Sam, would you like to start?
Yes, so Aram, thank you very much for the education on how, of course, drone is still being used to make sure that we take clear data-driven decision. Maybe what I would like to suggest that the future study, if you want to enhance it, because you are looking at data-driven and analytics, we could look at the same data and maybe get one of the, even Power BI, you can use Power BI to look at patterns of the data that are coming through, because that can help us draw some patterns, draw some visual, because managers today at the strategic level want to see a lot of visualization-based decision than just the raw fact of themes that we present. So your study could look at the data or using the drone data that has been used to generate more analytic-based outcome, so they can also make decisions out of that. So thank you very much for the enlightenment. Right.
Okay. Thank you very much for your recommendation. Yeah.
So my question is, have you implemented, I mean, you have implemented, it seems like you have implemented. How long you are using this utility, the one which you have designed?
I already implemented this. So this result part of my PhD study.
Okay.
Part of my PhD thesis. The whole thesis talk about promoting peace and tolerance through counter and alternative narratives. By multiple case studies, and one of the place is Muhammadiyah. So in Muhammadiyah, I found out the use of drone and print for their monitoring data. Yeah.
So that is something non-governmental organization, am I right?
Yeah, that's right. So Muhammadiyah
NGO?
is non-governmental organization.
Okay, it's NGO.
Yeah.
Okay, good. So you have collected all these data. These are all real data, right? I mean, you have not picked it up from any data set borrowed from any website. These are
No.
real Instagram feeds, I mean, posts and Facebook feeds, right?
Yeah, I collected it from the official report from the digital unit from this organization. So this this one is part of the report. Yeah.
Okay. Seems good.
Thank you.
You can improve and add the points as mentioned by Dr. Sam. Yeah, that's it from my side. Thank you.
Okay, thank you so much.
All right, so we'll now move towards the closing remarks. Aram, you can stop presenting.
Okay, I will.
Right. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative for everyone, and I hope that everyone had a nice chance at presenting their ideas. On behalf of the whole team, we thank you for your support during this 11th version and all the previous 10 versions of the conference, and we will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within the next 2 working days. And the publication will be live within the next 7 to 8 months. So we request you to kindly cooperate with the team of ICICT 2026. I would also like to thank our session chairs, Dr. Abiku Sam Edu and Dr. Sheetal Nayan Gilme, for chairing this session. And a token of our appreciation, I'm presenting a certificate for you guys. On behalf of the entire team, ICICT and Global Knowledge Research Foundation and partners, thank you so much for chairing this session today and gracing us with your valuable presence. Before we conclude, I would like to request everyone to please turn on their cameras for a quick virtual snapshot. All right. Thank you, everyone. Stay safe and take care. The session is adjourned.
Thank you very much.
Thank you.
Thank you very much.
Thank you, Dr. Sam.
Thank you, Nisha. I'll get in touch.
Yeah. Sure.
Okay,
We'll get
thank
in
you.
touch, sir. Yeah, see ya. Bye.